Hello everyone, so welcome to another video in our interview question series. So now this problem states as that we are given a tree, okay, and that's a binary tree in the sense every node will have maximum 2 nodes. It did not say balanced, so a node can have 1 or 2 or 0 nodes as well, right? Any root. So when it says like it is balanced, then every node will have 2 leaves or 2 nodes, all the left right nodes, right? So it is just said that it is a binary tree. Return all root to leaf path in any order. Forget about the any order, okay? So yeah, it says that we have to go from the root and we need to return all possible paths. So we have to traverse through all the paths from root. Let me explain this using whiteboard. So let's take an example tree that is root is 1, right? And every node will have a left and right pointer, and to left it will have 2, okay, and then for right let it call here, right, it has 5. Same way here, to do 1 it has 3. Okay, so in this particular case it asks that we have to traverse from the root to every node, right, and then we have to return the possible nodes. Okay, so in this case it says that we have to return, this is one root to leaf, that is 1 to 2 to 5, and another root to leaf is 1 to 3. This is what it wants as an array. So basically if there is maybe another node, let's call it like 6, right? So it would become the output would become 3 paths, right? Another would become like 1 to 2 to 6. So as we see, it is clear that it is a DFS, right? First of all, it is a DFS, so every time we have to find all possible paths to the leaf, and our best case is that whenever we don't have either, not either or, both, we don't have to have both end condition. If we don't have left and right, then we're going to return the node. Simple. Because if there is even one node left or right, we have to go through the left, right? Only at the leaf level, if we don't have left and right, we have to end our DFS there and return the value, and the value returned here will be, for example, for this path it will be 1 pointing to 2 pointing to 5. So since we are saving the value 1, 2 and 5 as for the output, so basically we need to keep track of from where we are coming from. So it makes clear that every time we call in our recursion, we have to pass the previously calculated value. For example, by the time we came to 2, our string will become 1 to 1 pointer, and if it goes to 6, we're gonna add 1 to 6. If it goes into this path, we're gonna add 1 to 5, and so on. So every time it comes from the root, we will keep constructing this string and keep reusing it or keep passing it as a parameter to our recursive function. Why it is clear? Because for example, it asked us how many nodes. Then we don't have to do that, because whenever we reach at 5, we just had to return 1. So we don't have to save any value in our path. But in this case, because it's asking the whole path, we have to keep saving all the values on the path. So let's try to solve this using JavaScript. So I created an example tree here, like binary tree, that has the same structure I used on the whiteboard, and I'm going to use the same structure or same tree in our example as well. So here now we're going to create a new function inside it, like function, let's call it create path. Yeah. So we don't have to pass, yeah, we have to pass node anyway. So let node equals to root, and we need a variable to store our result, right? That string and all. So let result to array. So every time we construct that string, we have to push that to our result. So basically what happened, our base case like if not node return, right? We don't have to do anything here. But if not node dot left and not node dot right, we have to push result dot push our string, and that string we will be construct from here. We're going to pass node, we're going to pass string. Simple. The initial value of the string will be space, right? And then here dot return, we now definitely have to call our left and right. Now we have to traverse through left and right. Simple. This is the basic skeleton structure of any tree DFS. Okay, there will be a base case and there will be two recursion calling, one for left, one for right. This is the basic structure. This is the what you say, this is the skeleton. Once you wrote that, then you have to adjust what output you need, and based on the output you have to manipulate these input values or do some arithmetic operations and those kind of stuffs. But the basic structure will be, you have to have a base case based on node, and then some other base case, and then other base case will be related to your result, and there will be two recursion call. One is for left nodes and one is for your right nodes. Simple. This is the skeleton. So let's do that. So we're gonna do like create path. One is for our left, node dot left. Then we're gonna create your string. Same way, create path node dot write, and we're gonna place string. Now here we have to construct our string. What is the string? String will be as we see in this example, node dot value, then we have to have an arrow signal, right? So we have to create that before pushing it. I think we can do it like that. String, then we're gonna do like this, then we're gonna press. No, the problem here is like it will give us wrong value based on if the first value is not there, then we don't have to add the arrow. So let's construct it outside. Let's create a temp variable. Let's make it temp, otherwise make it temp, and here we have to construct let temp equals to if str present, then we have to return str plus that arrow signal plus node.val, else we just have to return node.val. So this one is for the first value, right? First time when you encounter for one root, the root for one value 1, we don't need a arrow need to be added in front of it. That's why we did a conditional there, and this should work. So we have to return, we have to call create path. Okay, now we have to create path, then we have to pass node and string edge space, and then we're gonna return result. So the test case has failed, and let's see what's going on here. So here we are getting 1, 2 and 1, and if you see it's just not adding the last leaf. So we had a mistake in our push statement. So we are constructing a new temp here before passing it with using this arrow, but while pushing we are pushing the str, the string. So the string is not containing the current node value, this node value, and that's what happening. So we have to push the temp here, and that should solve our issue. Now let's run it again. Boom, so it passed. So yeah, so the only thing to remember is that every tree structure has a basic structure that we will have a base case, and there will be two recursion function going on to left node and right node and so on. That's the two things we have to remember whenever we are writing a DFS. So thank you.